History of the atoms. The journey to understand the atoms is a story of evolving ideas, brilliant experiments, and scientists building upon the work of their predecessors. It is a shift from pure philosophy to testable scientific evidences. Take two ancient Greek philosophers related to the history of the atom. Two philosophers well known related to atoms were Democritus and Aristotle. Democritus proposed that if you were to cut a piece of matter in a half again and again, you would eventually reach a point where it could not be cut any further. He called atoms, which means uncuttable or indivisible. Aristotle thought matter was continuous, or he rejected the idea of atoms. Matter made of four elements: earth, air, fire, water. His view dominated for several years. This was a philosophical concept, not dependent on experimental evidence. There are three fundamental laws that form the foundation of atomic theory. The first one is law of conservation of mass, or law of conservation of matter. In a closed system where matter cannot enter or escape, mass is neither created nor destroyed by chemical reaction. The total mass of reactant or starting material must equal the total mass of the product or the resultant material. This experiment did by Anthony Lavoisier in 1789. Let's take specific examples. Example 1. Burn 100 grams of wood. It turns into ash, smoke, and gases. If you could trap and measure all the products, the ash, the smoke, and the gas, their total mass would still be 100 grams. The mass has not disappeared. It has just changed form. The other take example, the reaction between hydrogen and oxygen. 2 moles of hydrogen plus oxygen, there is a formation of 2 moles of water. If 4 grams of hydrogen reacts with 32 grams of oxygen, we get 36 grams of water. We can add the reactant side, 4 grams of hydrogen plus 32 grams of oxygen. It gives us 36. And there is a formation of 36 grams of water. The mass of the reactant is equals to the mass of the product. This law we call it what? Law of conservation of mass. Second law, law of definite proportions or constant compositions. A given chemical compound always contains its component elements in a fixed and definite proportion by mass. No matter where a sample comes from or how it is prepared, a pure compound will always be made of the same element in the same ratio. This experiment done by Joseph pursued, and this law also known as the law of the pursuit. Let's take an example. Water from a tap, from a river, or synthesized in a lab, made from hydrogen and oxygen. The mass ratio is always 1 to 8 for hydrogen to oxygen. In a simple term, law of definite proportion states that a single compound always made from the same element in a fixed ratio and a constant composition. This law we call it law of definite proportion. The other, we can take an example of ammonia. Ammonia always made from nitrogen and hydrogen. Always made from 1 nitrogen and 3 hydrogen. It is always constant. We call it law of definite proportion. Third law, laws of multiple proportion or laws of Dalton. If two elements from more than one compound, the two ratio of masses of the second element which combine with a fixed mass of the first element are simple whole numbers. Take carbon plus oxygen, there is a formation of carbon dioxide. and there is a formation of carbon monoxide. From this we can understand two different compounds can form from the same element, but they have different in mass, they have different in ratio. Law of multiple proportion states that about the ratios. Take the mass of the carbon, 12 gram in both compounds, it is a common, and the second one is oxygen in carbon dioxide and oxygen in carbon monoxide. Oxygen in carbon dioxide we have 32 gram, and oxygen in carbon monoxide we have 16 gram. Take the ratio of the two oxygens. This ratio is 16 to 32. We have 1:2 ratio. This ratio is whole number ratio always. We cannot get 1.5 to 2 ratio or 1.3 to 2 ratio, or we cannot say 1.4 to 2 ratio. It is always whole number ratio, 1 to 2 ratio. The second one we can get sulfur and oxygen. These reactions, there is a formation of two different compounds. Those are sulfur dioxide and sulfur trioxide. Sulfur is common, the same mass, 32 gram in each. Then with the second element, oxygens, the second oxygen in sulfur dioxide has 32 gram, and the mass of oxygen in sulfur dioxide is 42 gram. Take the ratio of the two, 32 divided by 48. We can get 1:3 ratio. This ratio is simple whole number ratio. Atomic theory. Atomic theory is the way how we interpret facts about atoms. In this section, we are going to discuss the historical development of atomic theory. Dalton's atomic theory. Based on his explanation or based on his experiments with gases and chemical reactions, Dalton proposed the following postulates. First, elements are made of small individual particles called atoms. Second, atoms cannot be created or destroyed. Third, all atoms of a given element are identical in mass and properties. Fourth, atoms of different elements have different masses and properties. And the fifth one, compounds are formed by a combination of two or more different kinds of atoms in a fixed simple whole number ratio. Let us examine it from a modern perspective. The first one is atoms are indivisible. It is not correct because atoms are divisible into protons, neutrons, and electrons. After the discovery of postulates of Dalton's atomic theory, there are different experiments are done and discovery subatomic particles. The second point is atoms cannot be created or destroyed. It is true for chemistry. Atoms are conserved in chemical reaction. The third one, all atoms of the same element are identical. It is not correct because atoms of the same element can have different masses. These are called isotopes. They have the same number of protons but a different number of neutrons. Take example, carbon 12 we have, carbon 13 we have, carbon 14 we have. All are the same element but they have different masses. Take hydrogen 1, hydrogen 2, hydrogen 3. The other postulate is atoms of different elements have different masses. It is correct for most cases. The fifth one is atoms combine in a simple whole number ratio. It is correct. Due to limitations of Dalton atomic theory, led to modified and accepted theory. This theory called modern atomic theory. Modern atomic theory postulates are the following. The first one is what? Elements are made of small particles called atoms. Elements are made of small particles called atoms. Everything around you is made of elements like oxygen, carbon, and gold, and each element is built from tiny identical building blocks called atoms. Think of a solid brick wall. The wall is the element. Each individual brick is an atom. It is the first postulate of modern atomic theory. Second postulate: atoms cannot be created or destroyed during ordinary chemical reaction. You can build a car, then take it apart and build a spaceship. Both of them are different, but number and types stay the same. You just rearrange them. The other a previous example, water and oxygen. Hydrogen and oxygen can produce water. This water may be splitting into what? Hydrogen and oxygen. They have the same mass before and after the reaction. It indicates what? The law of conservation of mass. The third law, we take it. All atoms of the same element have the same atomic number but may vary in mass number or isotope. Every atom of oxygen has 8 protons. That it is atomic number. It is ID card. However, some oxygen atoms can have different numbers of neutrons, making them heavier or lighter. Means isotope. Imagine identical tunes. Imagine identical tunes, same atomic number. One tune is a basketball player and weighs more neutron. The other is a swimmer and weighs less, fewer neutrons. They are still tunes or the same element. The fourth postulate is atoms of different elements are different. An atom of gold is a fundamental different from an atom of oxygen because they have different protons, which gives them unique properties. We can't use wood to replace pen for a purpose of writing. The fifth one is atoms combine in small whole number ratio to form compounds. When atoms join together to make new substances, they always combine in a specific simple number ratio, like 1:1, 2:1, or 3:2. This is the law of definite properties. This postulate, we call it modern atomic theory postulates, and these postulates accepted in this time.